Hello students, welcome back to our channel Maths by SRAVAN VATAMBEDU. Hope you all doing well, and if you are watching our channel first time, do subscribe to our channel. In this video lecture, we are going to discuss about next problem. Evaluate integral over c f bar dot dr bar. The vector point function f bar is given. The curve, the region of integration is given, that is a rectangle in xy plane. Here, our region of integration is in xy plane, a rectangle, the coordinates are given. So x equal to 0, y equal to 0 represents x and y axis itself. We call x axis as y equal to 0 line, y axis as x equal to 0 line, the 2 over. Coming to x equal to a line, on x axis, for example, a is here. Here if you draw a line, that we will call it as x equal to a line. So this is x equal to a line. For example, if you assume here b is there, this is y equal to b line, x equal to a line. With these lines we will get a rectangle. This is region of integration. In this region we need to evaluate integral over c f bar dot dr bar. But this region is not formed by one line segment. It is formed by 4 lines in 4 directions, like this. This all we know. We call this one as origin, which is called 0, 0 point. This is on x-axis. On x-axis generally y coordinate is 0 because this is y equal to 0 line, another reason. Coming to here, this is the point on y-axis. On y-axis, x coordinate is 0. This is the point which is at on x-axis a unit distance and y-axis b unit distance. Now I am naming these points. Origin, a point, b point, c. Now to evaluate integral over c f bar dot dr bar, we need to evaluate the line integral along OA, integral over OA f bar dot dr bar, and integral over AB f bar dot dr bar, integral over BC f bar dot dr bar, integral over CO f bar dot dr bar. If you add all these integrals, we will get the complete integral over c f bar dot dr bar. So these directions along this line, along this one, along this one, along this one, using line. So after this we are going to discuss some vector integral theorems that we can easily evaluate this complete integral at a time by using surface integral, double integral. But our concept is line. This one we need to evaluate integral over c f bar dot dr bar in the given rectangular region. So first, as I said earlier, the given f bar is x square plus y square into I bar minus 2xy bar is given like this. You can write f bar dot dr bar directly by replacing I with dx, j with dy. Very shortcut. Otherwise, you can go with the actual procedure by taking r bar xi plus yj, dr bar equal to dxi bar plus dyj bar. If you multiply the two vectors by using the fundamental principle of vectors, I dot I 0, j dot I dot I 1, I dot I 1, j dot j 1, I dot j 0, j dot I 0. So by multiplying I coefficient, j coefficient, you will get like this. But here our concept is we need to evaluate this one, integral over c f bar dot dr bar we need to evaluate. To evaluate this, what I am saying, evaluate first integral along OA f bar dot dr bar plus AB f bar dot dr bar plus BC f bar dot dr bar plus integral over CO f bar dot dr bar. These integrals we need to evaluate. First, along OA, O 0, 0, A 0, to evaluate this. So here, in this direction we need to evaluate this line integral. For that you need to check which variable is varying, which variable is constant. So if you observe x coordinates, x coordinate is varying from 0 to a. So x is varying from 0 to a. So x limits are 0 to a. But y is constant. Y is not varying. Y equal to 0. So if you differentiate a constant, that becomes 0. Differentiation of constant. So dy becomes 0. Now to evaluate integral over c f bar dot dr bar here, integral over OA f bar dot dr bar, x limits from 0 to a, dy is completely 0. In f bar dot dr bar, this term completely 0, dy 0. Now write this one only, x square plus y square dx, in which again y is 0, y value 0. So if you write in the place of y 0, what is left over term you are having here? X square only. Integral x equal to 0 to a, x square dx. Integral x square, x cube by 3 from 0 to a. Write in the place of x a, what you will get? A cube by 3. If you write 0, that becomes 0. This is along OA. Next we need to evaluate the remaining directions along AB, along A comma 0, B, A comma B, in this direction. Again check x and y coordinates. So here x coordinate is not varying, constant. Y coordinate is varying from 0 to B. So here in this case, in this direction, x is constant. So differentiation of constant, 0. Y varies from 0 to B. Now we are going to evaluate integral over AB f bar dot dr bar. So y is from 0 to B, f bar dot dr bar, in this f bar dot dr bar, dx is 0 in this. In every case we are going to take that one only. Dx 0, completely 0. So dy term only you need to write. That is minus 2xy dy. Again, in the place of x, you need to write a. If you write in the place of x a, minus 2a is constant. What is integral y dy? Integral y dy, y square by 2. Limits from 0 to b. 2 get cancelled. If you write in the place of yb, what you will get? Minus ab square. After substituting upper and lower limits, these two get cancelled. Coming to next direction, BC. Along B, A comma B to C, 0 comma B. Again check, x coordinate is varying from A to 0, y is not varying, constant, y equal to B, y is B. So differentiation of constant 0, x is varying from A to 0. Now line integral along BC, integral over BC, f bar dot dr bar equal to x equal to A to 0. Here dy 0, this total term 0. What is left over? This one. X square plus y square dx. Again, what is y? Y is b. If you write in the place of yb, integral x equal to A to 0, x square plus b square dx. Now integrate. Integral x square, x cube by 3 plus. Here you don't have extra, that means you are having 1. Integral 1 dx is x, b square x, limits A to 0. So upper. Now we need to substitute limits. If you substitute upper limit 0, in the place of x if you write 0, what you will get? 0 minus, write in the place of x a. If you write in the place of x a cube by 3 plus b square a. Now multiply with minus to get final answer. Minus a cube by 3 minus AB square. This is along BC, last direction along CO. Along C, 0 comma B, O 0 comma 0. So here if you observe, x is constant, x is not varying, y is varying from B to 0. So x 0, dx 0, y is from B to 0. Now along CO, integral over CO, f bar dot dr bar equal to integral y equal to B to 0, f bar dot dr bar. In f bar dot dr bar, dx 0, dx is 0. We need to write dy term only. Minus 2xy dy, in which x is 0, this value is 0. If you write in the place of x 0, 0 into anything 0, integral 0, 0, integral 0 dy. So finally, as I write earlier, the total integrand value, integral over C, f bar dot dr bar equal to, you need to add first integral value, second one, third one, fourth one, all answers. Along OA, what is the answer? We got a cube by 3. Along AB, minus AB square. Along BC, minus a cube by 3 minus ab square. The final answer is 0. Now plus a cube by 3 minus a cube by 3 get cancelled. Minus ab square minus 2ab square. So like this one can easily evaluate whenever the region of integration is given in a rectangle. Okay, any doubts you may explain. Compute this line integral y square dx minus x square dy around the triangle whose vertices are given like this: 1 0 0 1 minus 1 0 in xy plane. So first we need to plot these points in xy plane so that we will get in which direction, along which direction we need to evaluate that line integral. So first I am plotting the points on xy plane. This is x-axis, y-axis. On this xy plane, I am plotting the points. Minus 1, 0. For example, minus 1 is here. Then minus 1, 0 will be here. Because y coordinate 0. The points in which y coordinate is 0, that points are in x-axis. So this point and this point will be on x-axis. Minus 1 comma 0 and 1 comma 0 will be on x-axis. Coming to x coordinate 0 in the next point. If x coordinate 0, then that point will be on y-axis. If you join these 3 points, you will get a triangle. You will get a triangle. So now, if you plot these points like this, you will get a triangle with vertices. If you give some names for these vertices, these 3 vertices, A, B, C. So along AB, along BC, along CA, we need to evaluate that line integral like this: along AB, along BC, along CA. So in these 3 directions, we need to evaluate the line integral. To evaluate the line integral along AB, BC, CA, first write the given integral. Integral y square dx minus x square dy. So here over C, the C is this one, the triangle. Along first direction I am taking, along AB, along A minus 1 comma 0 to B 1 comma 0. If you observe this direction, x coordinate varying, y coordinate is not varying. y coordinate is constant, y is 0, y is not varying. Then what happens? dy also 0. If y 0, what happens along AB? That value y square dx minus x square dy, y 0, right? y 0, 0 into dx minus x square into dy also 0. 0 into dx 0, x square into 0, 0. So finally in this direction you will get 0 only. Next, coming to next direction, along BC, B 1, 0, C 0, 1, in this direction. If you observe in this direction, x is varying, y also varying. When both are varying, you need to find the relation between these two. You need to find the equation joining B and C. The equation joining B and C. That will be x plus y equal to 1. How you can say? If you write in the place of y0, you will get x1. This one. If you write in the place of x0, you will get y1. Or you can use this formula, y minus y1 by x minus x1 equal to y2 minus y1 by x2 minus x1. These are x1 y1, x2 y2. If you use this formula, you will get the exact relation. Y1 you know, x1 you know. Y minus 0, x1 is 1, x minus 1 equal to y2 minus y1, 1 minus 0 by x2 minus x1, 0 minus 1. So y minus 0 is y equal to this x minus 1 I am taking, 1 minus 0 is 1. Here x minus 1 you will get, by minus 1 you will have. This minus 1 I am taking to here, otherwise next step. Minus 1 if you take to here, minus y equal to x minus 1. Get minus y to that side, minus 1 to this side. What I am saying? Take minus y to here, minus 1 to here. Then what you will get? 1 equal to x plus 1. So this is the way finding the equation between the 2 points when 2 variables are varying. Coming to the previous case, here one variable is fixed, 0 to 0. Then you can fix y, then dy becomes 0. This complete term becomes 0. You need to integrate with respect to x only. There no need to use this technique. This is the case where x coordinates are varying, y coordinates also varying. When both x and y are varying, there you need to apply this technique to find the relation. Now x plus y is 1. What is y? Y is 1 minus x. Dy will be differentiation of 1 is 0 minus dx. Now substitute these in this integral along BC. But we are converting complete integral in terms of x. We are going to write in the place of y 1 minus x and in the place of dy minus dx. When you are converting complete integrand in terms of x, you need x limits. Here you will get x limits 1 to 0. X is from 1 to 0. Now integrate integral over BC, that value y square dx minus x square dy equal to integral x equal to 1 to 0. Write in the place of y 1 minus x. 1 minus x whole square dx. X square will be same. Write in the place of dy minus dx. So what you will get? Integral x equal to 1 to 0. 1 minus x whole square dx, minus into minus plus x square dx. I am separating integral with same limits 1 to 0. So integral x square x cube by 3 integral x power n. x power n plus 1 by n plus 1, like that. Integral 1 minus x whole square dx will be 1 minus x whole cube by 3 plus integral x square is x cube by 3. But one thing we need to remember here, after integrating this term, you need to differentiate internal. Differentiation of 1 is 0, differentiation of x 1. So minus 1 you will get. That minus you need to write in the denominator. After integrating this differentiation term, you need to write in the denominator. Differentiation of 1 is 0, differentiation of x1 minus 1 you will get here. Now write in the place of x0 first, next 1. If you write in the place of x0, what you will get? Minus 1 by 3. This becomes 0. When you write in the place of x0, this is upper limit. Minus lower limit. Write in the place of x1. If you write in the place of x1, 1 minus 1 is 0. 1 minus 1 0. Plus 1 by 3. So what you will get? Minus 1 by 3. Minus into plus. Minus 1 by 3. Minus 2 by 3 will get along BC. Next direction. Along CA we need to find. Along C. Minus 1 comma 0. Sorry. C 0 comma 1. Along C 0 comma 1. A minus 1 comma 0. Along CA. Here also x terms are varying, y terms also vary. 0 to minus 1, 1 to 0. Then I said this technique. If you apply this technique here, you will get exact relation. So the technique very simple. Y minus y1 by x minus x1 equal to y2 minus y1 by x2 minus x1. Here this is x1, y1, x2, y2. Y minus y1, y minus 1 by x minus x1, x1 0. y2 minus y1, y2 0, y1 1. x2 minus 1, x1 0, minus 1 minus 0. So y minus 1, here 0 minus 1, minus 1, minus 1. By x, minus minus cancel. So what you will get? Y minus 1 equal to x. Y equal to 1 plus x. If you set minus 1 to that side, plus 1. So the relation between these two is y and x are related like this, or y minus x equal to 1. Y, in the place of y write 1 plus x here, and in the place of dy write dx. Now integral over CA, integral over CA y square dx minus x square dy. X limits, we are converting the complete integral in terms of x, so we need x limits. X limits are 0 to minus 1. So x equal to 0 to minus 1. What is y? 1 plus x whole square dx minus x square dy is dx only, dx. So if you see that, like previous one, like this, integral x power n plus 1 by n plus 1, 1 plus x whole cube by 3. Again if you differentiate internal term, differentiation of 1 is 0, differentiation of x1 plus 1 you need to write in the denominator. 3 into 1, 3 only, no need to write. Coming to here, integral x square x cube by 3 from the limits 0 to minus 1. Okay, now write in the place of x minus 1. Write in the place of x minus 1. What you will get? 1 minus 1, 0. If you write in the place of x minus 1, minus 1 whole cube by 3, minus 1 by 3. Now write in the place of x0, lower limit. If you write in the place of x0, what you will get? 1 by 3 minus 0. What you will get here? Minus into minus plus. Plus 1 by 3 minus 1 by 3, which becomes 0. 1 by 3 minus 1 by 3. Finally, we need this value, integral over c y square dx minus x square dy value. This value will be the total value along three directions. In this direction you know one value, in this direction you evaluated one value, in this direction you evaluated another value. You need to add all the three values to get final answer. First one answer is 0. Second one answer is minus 2 by 3. Third one answer also 0. So finally what you will get? Minus 2 by 3. Clear? Any doubts you may ask anywhere. Find the work done by force F bar in xy plane along the curve, this one, circle actually. So in xy plane z0. So clearly in the starting itself we can write in xy plane z0 and dz0. Then F bar becomes like this. If you write in the place of z0 in F bar, 2x minus y into I bar plus x plus y into j bar plus 3x minus 2y into k bar. But what happens dz0? In F bar dot dr bar, you will get in the place of I dx, in the place of j dy, in the place of k dz. Because dz0, you no need to write this term. These two terms are enough. 2x minus y into dx plus x plus y into dy. Because dz0, we are not going to write this term. 3x minus y into dz becomes 0. 3x minus 2y into dz we need to write because dz 0, so up to dy is enough. This is f bar dot dr bar. We need to evaluate this one along the circle. The given circle is x square plus y square equal to 9, which is 3 square. This is circle equation. Whenever if you have a circle equation in the region of integration, you can convert the given integral in polar form. You can easily evaluate that integral. Instead of writing in the place of y root 9 minus x square, y square equal to 9, y equal to root 9 minus x square. That transformation you need to use here to convert complete integral in terms of single variable. So that what we need to do here, instead of evaluating the problem in Cartesian form, evaluating in polar form is easy. That's why we are preferring polar form. To convert this Cartesian problem in terms of polar, you need to transform, you need to substitute in the place of x r cos theta. Here r is this one, r square, 3 square, r is 3 cos theta. Y is r sin theta, x r cos theta, y r sin theta, 3 sin theta. Now dx, differentiation of cos theta minus sin theta. So you will get minus 3 sin theta d theta. dy, differentiation of sin theta cos theta d theta. Differentiation of sin cos. Now because this is circle of radius 3 units. 3 units. So in circle from here to complete one circle, the angle in the complete circle is 2 pi starting from 0. So here theta is from 0 to 2 pi. That's why integral over c f bar dot dr bar is work done. Work done formula, work done by force equal to integral over c f bar dot dr bar. This we need to evaluate. For that we written f bar dot dr bar. Next, along this curve is a circle. We need to evaluate this integral, this integrand, because this is a circle. Evaluating this one by converting in polar form is easy than Cartesian. That's why we are converting this integral in terms of polar. In polar, to convert this one, we are using these substitutions. Integral theta equal to 0 to 2 pi. Theta equal to 0 to 2 pi. In this, write in the place of x 3 cos theta. In this 2x minus y, 2 into 3 cos theta minus y. Y is 3 sin theta. Next dx. What is dx? Minus 3 sin theta d theta. Okay. Next, coming to this one, x plus y dy. What is x? 3 cos theta plus 3 sin theta, x plus y. Dy 3 cos theta d theta. So simplify very carefully. Theta equal to 0 to 2 pi. So here 2 3s are 6. Okay, this is one term. 6 cos theta you are having. Here 3. 3 6s are 18 cos theta sin theta. Minus into minus plus. 3 3s are 9 sin square theta. We will write d theta at the end. Coming to here, 3 3s are 9 cos square theta. 3 3s are 9 sin theta cos theta, cos theta sin theta d theta. Now integral theta equal to 0 to 2 pi. See here, minus 18 cos theta sin theta is there, plus 9 sin theta cos theta. So minus 18 plus 9, minus 9. Minus 18 plus 9. 9 cos theta sin theta. Coming to these two terms, 9 sin square theta plus 9 cos square theta. You can take 9 common. What you will get? Sin square theta plus cos square theta. Sin square theta plus cos square theta, we all know 1. Sin square theta plus cos square theta is 1. Now coming to here, integral theta equal to 0 to 2 pi minus 9 cos theta sin theta plus 9 d theta. So if we have here 2 cos theta sin theta, that one we can written as sin 2 theta. We all know that formula, this formula. 2 cos theta sin theta equal to sin 2 theta. To get this formula, what I am doing, I am multiplying complete one with 2 and dividing with 2. I am writing here 2, here 2, into 2. I am multiplying and dividing. Here you are having 2. 2 cos theta sin theta. What is 2 cos theta sin theta? Sin 2 theta. 1 by 2 into integral theta equal to 0 to 2 pi minus 9 sin 2 theta. This one only we are applying formula. Plus 9 2s are 18 d theta. Now we integrate. Integral sin theta minus cos theta. But integral sin a theta minus cos a theta by a. That means minus 9 will be there. Integral sin 2 theta minus cos 2 theta by 2 plus 1 d theta. Integral 1 d theta theta 18 theta from theta equal to 0 to 2 pi. We need to write theta 2 pi first, next 0. If you write in the place of theta 2 pi minus 9 by 2 into minus into minus plus, this becomes plus 9 by 2 cos 2 theta. I am writing in the place of theta 2 pi. If you write in the place of theta 2 pi, 2 2s are 4, 4 pi cos 4 pi. Now write here in the place of theta 2 pi 18 into 2 pi. This is when you write in the place of theta 2 pi. If you write in the place of theta 0, if you write in the place of theta 0, what you will get? 9 by 2 cos 0 1, cos 0 1, cos 0 you will get, but that becomes 1 minus 0. So if you write in the place of theta 0, you will get 0. 18 into 0. So 1 by 2 into, coming to here, cos n pi is minus 1 whole power n. Cos n pi minus 1 whole power n. Coming to cos 4 pi minus 1 whole to the power of 4. Minus 1 whole to the power of 4 is plus 1. Cos even pi you will get plus. So cos 4 pi is 1. 9 by 2 plus 18 to the 36 pi. 18 to the 36 minus 9 by 2 because cos 0 1 plus 9 by 2 minus 9 by 2 get cancelled. So 2 1 jar 2 18 jar. If you cancel, you will get the answer, final answer. 2 18s. 18 pi is the answer. The clear explanation is given. You can see for everywhere I written formulas, the reasons also. Okay, any doubts you may explain. Find work done in moving a particle in the force field. The first bit, the force field is different, this one and this one, but along the direction, straight line is same from 000 to 213. So coming to the first one, a bit, f bar is given like this, 3x square I bar plus j bar plus zk bar. Work done, we all know, work done by a force. Formula is integral over C f bar dot dr bar. That we need to evaluate. So f bar dot dr bar, I said one small technique to find f bar dot dr bar directly. Simply write in the place of I dx, in the place of j dy, in the place of k dz, you will get f bar dot dr bar from f bar directly. So write in the place of I bar dx, 3x square dx, in the place of j dy plus z dz. In the place of k dz. Now you need to evaluate integral, but here we don't have any problem to evaluate directly because while integrating with respect to dx, we are having x terms only. Here integral 1 dy by integral z dz, you can integrate z square by 2. While integrating with respect to z, do you have z terms? No need substitution, transforming one variable to another variable. So this case we can evaluate directly by taking the given directions. X is from 0 to 2, y is from 0 to 1, z is from 0 to 3. So you can easily find out x limits and y limits and z limits here very clearly. X 0 to 2, y 0 to 1, z 0 to 3. So like that we can write the limits. Now I am going to evaluate integral over C f bar dot dr bar equal to this one. Integral x equal to 0 to 2 3x square dx plus integral y equal to 0 to 1 dy, integral z equal to 0 to 3 z dz. So 3 into integral x square x cube by 3 limits 0 to 2, integral 1 dy by 0 to 1, integral z square by 2 from 0 to 3. So here 3 get cancelled. If you write in the place of x2, 2 cube plus 1 plus write in the place of z3, 3 square 9 by 2. 2 cube 8 plus 1 9. So 9 plus 9 by 2, 9 2s are 18, 18 plus 9, 27 by 2 is the first one. Okay, now coming to the second bit, B bit. Here f bar is different. F bar is 3x square I plus 2xz minus y j plus zk bar. As earlier I said, f bar dot dr bar you can write directly by writing in the place of I dx, in the place of j dy, in the place of k dz. Okay, now here no problem, x square dx. Here no problem, here only we are getting problem. While integrating with respect to y, you should have here only y terms. But here you are having x and z. Then you need to convert the complete function in single variable by using one relation. Here, along AB direction, for example, these are the points. Along 000 to 213, if you observe, every variable is varying. X is varying, y is varying, z also varying. No variable is constant. Then you can find the relation using this formula. X minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. So what you will have? x1, y1, z1 are this one, x1, y1, z1, x2, y2, z2. What you will get? X minus 0 by x2 minus x1, 2 minus 0, 2. Y2 minus, y minus y1, y minus 0 by 1. Z minus 0 by 3. So x minus 0 is x by 2 equal to y equal to z by 3. If you assume these all to some constant t, then you will find one common relation between x, y, z. X can be written in terms of t, y can be written x by 2t, then x will be 2t, y equal to t, z by 3t, z will be 3t. Now you can replace dx with 2 dt, dy with dt, dz with 3 dt. Okay, now integral over c f bar dot dr bar, because we are converting complete function in terms of t limits will be y limits, because y equal to t. So what are t limits now? Here you can find y is 0 to 1, so t also 0 to 1. Integral t equal to 0 to 1 f bar dot dr bar. Here very clear, in this write in the place of x 2t, write in the place of z 3t, write in the place of yt. So if you write, what you will get? 3x square dx, 3 into 2t whole square dx is 2 dt, plus 2xz, 2 into 2t into z 3t, 2xz minus y is t, dy is dt, because dy is dt, I am writing dt, z dz, z is 3t, z 3t, dz 3 dt. So finally integral t equal to 0 to 1. See here 2t whole square is 4t square, 2t whole square, 3 4s are 12, 12 2s are 24 t square, 2t whole square there. Coming to here, 2 2s are 4, 4 3s are 12, 2 2s are 4, 4 3s are 12, t square minus t. The last one, 3 3s are 9t dt. So finally what you are having? T equal to 0 to 1. T square terms, if you see, 24 plus 12, 36. 36 t square. Coming to here, 90 minus t. If you subtract 1t from 90, 8t you will get dt. So that equal to integrate 36 integral t square t cube by 3 plus integral t square by 2. So 3 1s are 3 12s are 2 1s are 2 4s are 0 to 1. If you write in the place of t1, you will get 1 only. Simply you need to add these two, 12 and 4. 12 plus 4, 16 is answer. If you write in the place of t1, you will get 12 plus 4. If you write in the place of t0, you will get 0. Okay? Any doubts you may express?